Good day viewers, you're welcome once again to another interesting tutorial time with Jot Tutors. We believe you've been able to learn one or two things from our previous video, and please we're encouraging you to please like our video, share it, and also subscribe on our YouTube channel. Please you can as well tell your friends and loved ones to subscribe. The advantage of it is just that you will be the first to get our new video anytime it is out. It is free. You are not paying anything for it. Please subscribe. Thank you very much. Today we are looking at number patterns, sequences, and series. Number pattern, sequences, and series. This is a very important topic in mathematics, and it can appear in several ways. Like for instance, I might decide to write 1, 5, 0, 5, 10, 15, and so on and so forth. This is a sequence and it follows a regular pattern. I can decide to also write 1, 10, 100, and so on and so forth. This is also another pattern. So number pattern can appear in different form, in different ways, and we are going to be looking at them one by one. All right, first and foremost, let's look at the known sequences. The known sequences. All right. Number one, we might have arithmetic series or sequence or pattern. We can have geometric series, sequence, and pattern. Also, we might have some other types like quadratic and so on and so forth. We are still going to look at other type when we are solving some questions. All right, so at this point, let's begin to take these known sequences one by one. I will explain briefly, and please, if you are interested for online tutorial, you can see the number below and contact us anywhere in the world. So we'll take them one by one. And the first thing we are looking at is arithmetic sequence. And in arithmetic sequence, let's say for instance, I have this pattern 0, 5, 10, 15, and so on and so forth. If you look at this, the pattern follows a common difference, because the difference between 5 and 0 is 5, 10 and 5 is 5, 15 and 10 is also 5. So it has a common difference. That is one of the major points by which we identify our arithmetic sequence. Common difference. The common difference is denoted by D. We normally represent it by the letter D. There are some other things we have to know when we are dealing with arithmetic sequence. Now, the first term of an arithmetic sequence is always denoted by T1, or sometimes we refer to it by A. So some people can use the letter A, some people can use T1. All right, with the arrangement we have above, the second term, definitely, it's going to be T2, which is the same thing as A plus the common difference. Like for instance now, if you had 5 to 0, you are going to get 5, which is the second term. If you had 5 to term 2, you are going to get 10, which is term 3. So let's look at third term. Definitely is going to be what? T3, which is the same thing as A plus D plus another D, which is the same thing as A plus 2D. I hope you are following this. So if you look at the arrangement and the pattern, we can easily determine what the 9th term, the 10th term, the 100th term can be. Okay, let's say for instance, we have the 9th term. The 9th term is going to be T9, which is going to be what? It's going to be A plus 8D. Very simple. Now, let's go to the nth term. Let's say if a particular term we don't know what it is, we call it nth term. So definitely my n term, which is Tn, is going to be a plus bracket n minus 1 multiplied by the difference. And this is actually what we use a lot in arithmetic sequence. I hope you are following this. All right. Before we go into some questions, we are also going to talk about some things about when we had terms in a sequence together, which becomes a series. Anytime we had terms in sequence together, it becomes a series. Let's see what we are talking about. So now let's look at some of arithmetic series. As I've said earlier on, we are dealing with the types of number patterns we have, and we are taking them one by one. We're first of all looking at arithmetic sequence, and now we are looking at the sum of arithmetic series. Let's say, for instance, we have 2, we have 4, we have 6, we have 8, and so on and so forth, and we are asked to add it together. I'm not going to prove the formula, but it's a formula that every learners have to be aware of, and you should be able to use it to apply it appropriately with the question. We have two basic formula for sum of arithmetic series. The first one tells us that when you are adding together a series of numbers that follows a common difference, we're going to have n over 2 bracket 2a plus bracket n minus 1 and the difference. Please note this. There is a proof for this formula, and please, learners are advised to check their textbook for this, but please note the formula. The second formula we can use for sum of arithmetic series is n over 2 brackets a plus L. A plus L. Please note this. A plus L. Now, the L here is actually the last term. The A is the first term, also known as T1, don't forget, and the N is the terms that appears in the series. Please don't forget, also this one is a common difference, and at least everything is plain now. Sometimes also in some of arithmetics we use sigma notation. Please don't forget, and n equals to something. We can say from n equals to 1, or we can say k equals to 1, and so on and so forth. Then we'll define it with what it is. We are still going to look at some questions related to this, but please, the sigma also means sum. Don't forget, the sigma also means sum. All right, let's check one or two questions before we go into other types of number pattern. Thank you very much. All right, so let's see a question under arithmetic sequence. The question says p, 2p plus 2, 5p plus 3, and so on and so forth are the first three terms of an arithmetic sequence. Calculate 1, the value of p, 2, determine the sequence, that is, define the sequence, the end term of that sequence, like the formula of the sequence, and 3, find the 49th term of the sequence. Very simple question. Now, to look for the value of p, we must note something. For every arithmetic series, every arithmetic sequence, the common difference is always the same. That is, the difference between the second term and T2 minus T1 must be equal to T3 minus T2. T2 is the second term, T1 is the first term. When you subtract it from each other, you must get the same value as T3 minus T2. So let's put them into what we actually have on the board. So T2, we have 2p plus 2 minus p must be equal to 5p plus 3 minus bracket 2p plus 2. We have to put them in brackets so as to guide the subtraction sign. It's most because it's applicable to all the numbers for term 2. So let's resolve this. When you subtract this, we have p plus 2 must be equal to, when you expound this, it becomes 5p plus 3 minus 2p minus 2. And 3 minus 2 will give us 1. 5p minus 2p definitely will give us 3p. So let's resolve them. We have p plus 2 is equal to 3p, and we have plus 1. Very good. All right, so let's collect the like terms. I can transfer my 3p to this place. I can take my p to the other side. So let's say I'm bringing this. I have minus 3p plus p equals to 1 minus 2. Then I'm going to have minus 2p equals minus 1. When we divide both sides by minus 2, definitely we're going to have p equals 1 over 2. So the value of p for the question given is actually 1 over 2. Now the second question says determine the sequence. Number 2, to determine the sequence, definitely we are looking for Tn equals a plus bracket n minus 1 then d. This is actually what we are looking for, but we have to substitute each of the values into this. So let's see how this goes. So for question 2, we are asked to determine the sequence, and as I've said earlier, we wrote this thing again here. Tn equals to a plus n minus 1 d. Let's substitute those values. We've already gotten our p to be 1 over 2. So definitely the first time will be 1 over 2, which is T1, which is the same thing as A in the formula. The T2 is going to be 2P plus 2, which is 2 multiplied by half plus 2. If you resolve this, definitely we're going to have 3. And my T3 is going to be what? It's going to be 5P, which is 5 and a half. 5 multiplied by half, 5 multiplied by half plus 3, and it's going to give us 5 1 over 2. 5 1 over 2. Definitely the common difference, if we look at this, it's going to be what? It's going to be 2 and a half. It's going to be 2 and a half. The common difference is going to be 2 and a half. So we can substitute all those values into the equation of an arithmetic sequence n term. So let's see. So Tn is going to be 1 over 2 plus bracket n minus 1 2 whole number 1 over 2. That is the sequence. That is the definition of that sequence. That takes us to the third question. The third question says, now find the 49th term of the sequence. The 49th term is very easy. T49 definitely is going to be half plus bracket 49 minus 1, then 2 whole number 1 over 2. A 2 whole number 1 over 2 can be written as 5 over 2. It can be written if we change it to improper fraction. When we resolve this, definitely my T49 calculator 120, 120.5, and that is the solution to the question given above. I believe you have been able to learn one or two things. Now at this point, let's go into the quadratic pattern. Sometimes we might have a quadratic pattern in a sequence. So let's see. Thank you. Let's look at quadratic pattern. A quadratic pattern, it is usually defined by this: Tn equals an squared plus bn plus c. This is actually how a quadratic pattern is. But how do we recognize a quadratic pattern? Let's say, for instance, we have T1 equals to a plus b plus c. T2 equals 4a plus 2b plus c, and t3 times 3, let's say we have equals 9a plus 3b plus c. All right, that is a pattern. We can go on and on and on and on to 4 to 5 and so on. Now, the first difference between the second term and the first term definitely is going to be 3a plus b. 3a plus b. If you resolve it very well, this is the first difference. Let's say first difference is going to be 3a plus b. If you do for this, the difference are not going to be common. It's going to be different. So we're going to have 5a plus b. But let's see. If we bring this together, we're going to have 2a. If we bring this together, we're going to have 2a. If we continue this trend like that, the second difference is going to be the same. The second difference is going to be the same. We're going to have 2a and so on and so forth. It's going to be the same for the second difference, but the first difference is not going to be the same. So these are the ways by which we identify quadratic pattern. The first difference will not be the same, but the second difference will definitely be the same. Now, how do we get the pattern? Very simple. Anytime we have a questions like this, we must first of all define the first difference for each of the term. Then we get the second difference, which is common to all of them. When we get this, we can use that to get my A, we can use that to get my B, and also we can use that also to get my C. I believe we are cleared with this. Maybe I should do a little more explanation on this. That means my A plus B plus C is going to be T1 for the sequence. It's going to be T1 for the main sequence given. All right. Then my 2A is going to be the second difference, which is common. It's going to be the second difference, which is common. And my 3a plus b, is going to be the first value of the first difference. Please note it, the 3a plus b. So whatever is here, we are going to check some questions now. Whatever is here is defined by 3a plus b. Whatever is here is defined by 2a. And whatever is here is defined by a plus b plus c. Please, I want us to note this. It is very simple. It is not difficult. And please, for all our viewers, if you are struggling with some of these questions or this topic, please, you can message us. You can write to us. Also, after this short tutorial, we are going to give some questions. Please encourage yourself to solve this question. It gives you more enlightenment about the topic. Thank you. So now let's see a question related to the quadratic pattern. So this is a question under quadratic pattern. Sometimes the quadratic pattern will be mentioned in the question. Sometimes it will not be mentioned, but the learners are expected to know it. So let's say the question. The question says the first 4 terms of a quadratic number pattern are -1, -1, 2, 9, and 20. Determine the general term of the sequence. The general term of the sequence. I mentioned it earlier, what the general term is. The general term actually is the Tn equals an squared plus bn plus c. All right, I'm still going to write it again, but I just want to put it here so that we will not forget. All right, so now let's do some analysis on this. If we bring this and this together, what is the difference between 2 minus minus 1. Definitely we're going to have 3. What is the difference between 9 and 2? Definitely we have 7. And what is the difference between 20 and 9? We're going to have 11. Okay, that is the first difference. Now the second difference, let's see what we're going to have. 7 minus 3, we're going to have 4. 11 minus 7, we're still going to have 4. Just like my explanation, it is very easy. The second difference is going to be constant as we go on, but the first difference is not going to be constant. Now remember something. We remember that the second difference, which is common, is going to be 2a. We remember that my 3a plus b is going to be the value of the first difference, while this one will be a plus b plus c. Irrespective of the numbers that are here, please, we have to equate it as stated. These are the standard. These are the standard. So very easy. So now let's look for the value of a, which is the most easiest of them all. My 2a equals to 4. My a is going to be 4 over 2 is going to be 2. We should note that. That's the value of a. I can as well go ahead to solve for b. Now I've gotten the value of a. For b, I have 3a plus, let me write it again. I have 3 bracket 2 plus b equals to 3. If I resolve this, I have 6 plus b equals to 3, and my b equals minus 3, because 6 will be taken to the other side, becoming minus 6, and b is minus 3. Then for c, now I've gotten my a, I've gotten my b, I can get my c, because my a plus b plus b plus c must be equal to minus 1, is the value of the first term of that sequence. So let's bring them together. My a is already 2 minus 3, which is the value of my b, then plus c must be equal to minus 1. Let's resolve it. If I add this together, that will be minus 1. If I take the minus 1 to the other side, my c is going to be 0. It's going to be 0. It's going to be 0. So now if I have to write the term, as written here, so now we've gotten the value of c. So now we have the value of a, the value of b, and the value of c. So now to bring them into the general term for a quadratic number pattern, we have my a, which is 2n squared. B is minus 3. So it's going to be minus 3n equals tn, because my c is a 0, so it doesn't have a space in the term. So this is the final answer for the general term of the sequence. Very easy, very easy. We started from here. Please observe it, then we ended here. Thank you very much. Let's go to the last question. Calculate the value of the 48th term. To calculate the value of the 48th term, T48 is now what we are looking for. Now we have been able to determine the general term of the sequence, which we are going to use. So now we're going to have 2 bracket 48 squared minus 3 times 48. Very easy. If we calculate this very well, we're going to have very large number, very simple, but it's going to be 4464. 4464. Just press your calculator, the square of 48 multiplied by 2, subtract it from the multiplication of 3 times 48. We're going to have T48 equals to 4464. All right, we believe you've been able to get 1 or 2 things today. Now, watch out for our assignment. Watch out for our assignment. This are the assignment for today. The first question says x plus 3, 2x plus 6, 3x plus 9 are the first 3 terms of an arithmetic sequence. Determine the 10th term in terms of x, and b, determine the nth term in terms of x. Please, I want our viewers to attempt it. And the second question says the first term and the last term of an arithmetic series is 5 and 61 respectively, while the sum of all the terms is 957. Determine the number of terms in the series. This is about sum and also in conjunction with the term of the series. Please, we implore everybody, please, to attempt it as you watch it. Please, you can do it as group work. You can do it alone when we are less busy. Please, we want to beg you, like, share our videos, and subscribe as well. Thank you very much. See you next time when we continue with the topic number patterns, sequences, and series. Thank you.